I will present how to run a Python free application using the Django 4 framework on the Timoni platform. I need a Git repository where I can place the files of my application. To do this, I open the Timoni management panel in my browser and select Git repository from the main menu. Then I create a local repository. Next, I copy the URL that allows me to download the new repository to Visual Studio. Using the clone Git repository, for Django to work properly, it needs a settings by file that contains the application settings. The file can be downloaded from the official Django website. Additionally, I need to create a Timoni directory and within it a Django TOM file. In this file, I will define the instruction for Timoni on how to build and run the application. I have prepared the contents of the file earlier. The file is divided into 4 sections. In the first, we specify the type of element and the command that will run our application. In the build section, we describe how to build the Django container image. The instruction is written in Docker file format. Here we also copy our settings by file to the container image. Then in the expose section, we specify the port on which our application is running and specify the service type as HTTP. In the variables section, we set the required environment variables. Finally, we send the created files to the Git server. Now we return to the Timoni panel. In the commits tab, we can verify that our changes have been sent. Now I create a new environment in which I will place the application. I set the name of the environment and choose the team that will have permission for the given environment. In the element tab, I add an application element. I use the option element from Git and search for the element by name. I add the element and wait for it to start. At this point, Timoni has determined that the image for this element is not built and has started the build process. Here we can see the logs from the entire process. If there were any problems, I would receive feedback with an error. To make my application work properly, I will also add a domain. For this, I will use the Visual Creator. I set the name of our domain and then assign the Django element to it. I see that the two elements are ready, so now by clicking on the domain address I can see if our application is working. Everything looks okay. Now I will demonstrate how trunk-based development could work where multiple programmers work on one branch. For example, a programmer makes a modification to the code of the application in the repository. I make a small modification in setting spy and then send it to the Git server. Now in the Timoni panel, we can press the button in the version column and I can see a new commit that I will apply. This is the simplest example of working in the trunk-based development in manual mode. I could also work in automatic mode, where after each code modification, the element is rebuilt to the latest version. To do this, I change the mode in the update column from manual to automatic and again modifying the code to demonstrate the operation. I see that Timoni has detected the new commit and start rebuilding the element. If I wanted to work in the feature branch model, the difference would be that I would not make changes on the master branch, but create a new branch for each function. To demonstrate this, I return to Visual Studio and make modification on new branch. I create a new branch and make an additional commits. In the Timoni panel, I switch the element to manual mode. I click on the version changes button and from the list I select the new branch and choose the commit. In this way, I have changed the given element to a specific branch and environment. On this feature branch, I could also turn on the automatic mode as before. Another thing I would like to demonstrate is cloning environments. We go to the environment view. With the clone environment button, I can quickly create a new environment based on an existing one. I enter the name of the environment and select the cloned environment. With one quick click, I created a new environment that gets a copy of all elements. The only thing I need to do is modify the domain address. At this moment, I have two environments. At any time I can stop or delete them. Here, I will show the deletion of the environment. We click on the delete button and our environment is deleted. Stopping, on the other hand, involves going to the element tab and selecting the start stop element option. I select all elements and confirm the change. Stopped elements are removed from Kubernetes and release resources, but they are still visible in the panel and all data is preserved. Thank you for your attention.